So, hello everybody. It's a pleasure to be here. And in this session, we will talk about how we built Spring Boot-based modular libraries for 120 teams in Ocado Technology, and which are our findings and our experience in general. This is briefly the agenda. We will introduce you about what is Ocado Technology, then a brief summary about what are our libraries, and then we will talk about how we make it work at scale, working with the community, software design, and engineering practices. So let's start talking briefly about Ocado Technology. This is not a marketing slide, but it's useful for you to know a bit of the context why this library has been built and which are some of the requirements that we had to consider when we built this library. So Ocado Technology is a company that provides end-to-end solution for online grocery. And our solution is called Ocado Smart Platform, and it's a suite that it's an end-to-end platform that covers all the steps of the online shopping journey. So as we know, the online shopping journey starts when we enter to a website or we use a mobile application to do shopping. So our platform provides all the application, front-end and back-end, that enable the client to manage an online store and a mobile application. So we have many services related to the online store itself. Then there are many other applications that help the client to fulfill the order. So Ocado Technology provides all the technology to build this massive fulfillment center with robots that automatically pick item and prepare the basket, but there are many services behind that help the client to manage the orders and, for example, to inbound the stocks and many other operations. The last step of the online shopping journey is the delivery. So our solution also includes many services that help the driver to reach customer houses and prepare optimized routes for the drivers and so on. So it covers really all the steps of the online shopping journey. Currently, our solution is used by 12 global retailers across all the world. And you can see that they have different scale. We have very big clients and very relatively small clients. So our solution must be flexible because each of our clients have different needs, and must be scalable because every client works at a different scale, basically. So this is a requirement for us, and we decided to use a microservice architecture because it helps us to be more flexible and also scalable. Indeed, our solution works running on the cloud, in particular in AWS cloud, that also helps us to deploy the solution geographically close to the location of our client. So this was a brief introduction of about what our company does. Briefly about us, I'm Fabio Pezzoni, senior software engineer. I'm working here in Barcelona. Nice place to work, so contact me in case you are interested. And I'm a contributor of the libraries we are talking about. So I'm talking more about the community perspective of these libraries. On my right, Jacek Kaczmarek is senior staff software engineer coming from Wrocław, Poland, and he is the most senior member of the owner team of this library. And now Jacek will tell you about the libraries that we built in Ocado Technology. Okay. So,
thank you, Fabio. So I'm sure you're here for the part about the how, and I promise you that's the longer part. But what is also important, so that to put you in the context, our library is actually for generically to see it for engineering productivity. So by the take of the pragmatic engineers blog by Gergely Orosz, and in particular Alexander Kanat Alexander's post about engineering productivity being about happy and developers who feel happy about the tools and that feel they are productive. So this is sort of our mission. In particular, I want to make their life easier with company standards like formats, like interoperability, with security, and have an up-to-date stack, meaning we are now on Spring Boot 3.06, for example, and we have an RC on 1.3.1. And the community of practice is super important also, so not losing touch with the community. Why these libraries exist, actually, we are asked a lot, and it's the main reason is like developers created them for themselves, so they felt the need to do that. And then they were adopted over time by many teams. And here I would like to stop for a while, because this is when there was a serious risk that the things would go wrong. Actually, we were close to a snowball effect when there were 90 contributors already. And then, unfortunately, somebody realized we should actually govern it properly and take it under control. So that's when the team decided to move together with that to an engineering productivity department that got budget, got more ownership, was refactored, modularized, and now it keeps helping users. Users actually like it, so it's not so typical. People are grateful, people like it. And that's why we think it's worth talking about it in a conference like this, so it works. The scope, so I could say more about the scope, but in general, we do two needs. One of them is the common aspects that all cloud applications do, or most of them. And dependency management, think Spring Boot dependencies, plus Spring Cloud, AWS, and a couple of others. There's more, of course. We'll talk more about that in the domain part, how we split the domain. But for now, it's important to understand the main premise. In particular, it's about things like easy creation of services at scale. Okay, sorry. Now I'm zooming out a bit. This is what our team does, and I'm saying for the team, but it's a wonderful team of just 7 developers, a product owner, and a team leader, and they do that. But we couldn't do it without the community. So we have a community of collaborating libraries. There's an ecosystem. You can compare it as a microcosmos of what the Spring people do. Like we have a framework, and there are like collaborating libraries that are aligned on values and on some practices. And it's more importantly a community of practice. So we blog together, we have exchange of practice also with the Scala guys, with the Python's guys. There's a lot of going on. Discussing whether reactive is a thing, whether native is a thing. We keep in this constant contact. The technologies we chose, marketing alert, Spring Boot Cloud and AWS, but it actually works. I've used to work in a couple of other technologies, and I find that actually Spring makes it easy for us to have common sense between developers, hire developers, has predictable upgrades, it actually does it really well, and the reliable security patching, and it allows configurability, which makes our mission easier because we want our libraries to be configurable. Now the form, you can think of it as a shop with modules. So you can find modules, you can search for them, and you can actually, each of them can be thought of as a mini product. They have their life cycle, they can be experimental, they can go out of use, and then it's an interactive web portal. So an example would be like a module for a health check. So why have such a module? Because those health checks have to be compliant with certain company standards. Or a starter for context passing, so passing of context attributes through typical integrations that we have. And as you see, they have their own life cycles. You can copy-paste them to your POM. We recommend users to go from start to Spring.io, and they can just add our modules. So it's living documentation in a way because that's created by POM XMLs and lightweight metadata files. So it's actually easy to maintain. We'll talk about it a bit more in the documentation part. The user build is actually quite simple. So we refer to Spring Boot dependencies, be that Gradle or Maven, plus a couple of other dependencies that we manage. And users have a normal Spring Boot application, and they just add our modules to their application. Because we want them to feel they are Spring Boot developers, they are not like vendor technology developers. We fought for a long time that our users stop thinking that we are a framework, because we used to be a monolith. It didn't work that well. So now that we are modular, people feel more in control. So they write their code in Spring. Our library is often invisible, and they can easily adopt or de-adopt the module. So what you see, the highlighted parts are familiar Spring Boot annotations and Spring security. Some of them are actually fine or resilience4j annotations. Some figures to end the section. We have 90 modules. We do 200 releases per year. As I said, we are on the latest version of Spring Boot now. 120 teams, and we have growth, meaning people want it because they don't have to use our technology, but for some reason they do. Okay, now moving on to the important section, how we make it work at scale. So a question to you, how many of you actually maintain or have maintained a library for more than 5 teams? Okay. How many have done it for more than 20 teams? Or okay, quite a few. So I imagine you know that is a big challenge. And of course, it depends. It depends on the culture of your company, on the standards, or the security restrictions, all that stuff, on how tolerant your customer is with that. So we actually observe the community, and we balance certain characteristics over time. So the next couple of slides will be like, can you imagine a mixer with sliders, values, or ilities, because we're really inspired by the Richard Ford book about software architecture, released 2 years ago, one of the better books I've read recently. And they say about ilities. So, for example, we want to be modular. If you see the gray arrow, it moves to the left, so it means we are more and more modular over time. Maybe not at all costs. Certainly not monolithic. We want our modules to be simple, and they become more simple over time. So whatever was complex, we make more simple, more intuitive. To offset that a bit, we make them configurable. We will show you in more details later how we do that in practice, but we have to somehow balance the simplicity to make them powerful. Spring is quite good at configuring things through various means. And we want to make them extensible, but then we are afraid of a bit of coupling with users, so we don't want to be coupled, so we have some ideas how to balance that. Another slide of the mixer, the dynamics. We want to be super predictable. So users should know what to expect. Doesn't mean we cannot change our software. Of course we can. It just have to be managed. And I'm sure Fabio will show you about how we know if we can change software. We want them to be up-to-date, not bleeding edge. So we didn't go straight on Spring Boot 3 when it came out. We did some research. We made sure that the third-party libraries were actually updated. And then we gradually moved on. I'll tell you more about the release model later. Secure, we cannot ensure full security of an application, of course. So we set up a baseline and do a lot of education, collaboration with our AppSec engineers. And we tell the user it's their role not to spoil security, but also harden security to the extent that they need it. So whatever CSP policy they may want to have, or are they more or less restrictive depending on the type of exposure. We had a discussion about how expose your APIs to your user. So this matters. And the last slide about characteristics, the community mixer, sort of. And this is a very important one. Like, on the folders page, there's a section in the micro frontends about shared libraries, and they refer to a balance between ownership and no ownership, saying in their take there should be a custodian who is the owner, but they accept contribution to not lose contact with the community. So this is what we do. We own the product, what we allow contribution. Fabio will tell you more about it later. Again, self-support versus ticket ops. So Michael Plett had a fantastic presentation today about us being actually also in charge of understanding the business. So we do want our users to be able to self-support, but we don't want to lose contact with our users, the developers, right? We want to understand what they want. We want to be able to segment them into segments. We want to understand which group is how large, what kind of impact it makes. Almost the last slider, ecosystem. So as I said, we are not one library with all the code. We don't want to be the bottleneck. We don't want to create a swarm of libraries, like 50 libraries would be hard to manage and hard to use. So we have an ecosystem. We spend time aligning on who does what. And lastly, we do some more narration recently and less discussion with the users because our community grows. It's, again, we'd like to discuss things, but cannot discuss them with everybody all the time. So now we'll move on to the practical stuff. How we make it work at scale. Working with the community, Fabio will tell you as a community member more about it. I will tell you then a bit about the software design and engineering practices. It's like holistic approach. Hopefully, whatever you are more interested in, you'll find something useful for yourself. Fabio, over to you.
Thanks, Jacek. So the first thing we want to share with you is how we work with the community to make this library work at scale. The community, by definition, is defined by the adopters of a product, libraries in this case. So the scale of adoption of our product is big because it's used by more than 350 applications in more than 20 production environments, so it's big numbers, you know? And big scale of adoption mean, of course, that we have a big community of users, more than 800 developers in more than 120 teams in 5 different departments, and this is can be a problem, no? So it's a big challenge for us, how we can manage such a big community of users. And this is our approach that consists of 4 different practices that I will explain you in detail, each of them. The first one is being custodians, then analyzing usage data, interacting with people, and creating narration. So let's start with the first one, being custodians, that has been introduced briefly by Jacek already. And it means that the owner team has the ownership of the project, of course, so decide what is the direction, how the project should evolve, which are the features to include, and so on. But it also allows contribution, and actually the owner team encourage contribution. There is a published contribution guide with a formal process of how to submit a minimal or a significant change. And actually the feedback we had from our community is very positive. Indeed, for 5 on average maintainers of the owner team, we had more than 132 contributors historically. So this is a good feedback from the community. It's something that it's really helping us to move on and to evolve our product. So this was the first practice that we follow when working with the community. The second, and one of the most important, I guess, it's analyzing usage data. So having the usage data and being able to analyze them, it's very important because, at least for two reasons. For supporting the decision process, so every time we need to decide something, we always check the data, and also for user discovery. I will tell you later a bit how we use data for user discovery and why. So the prerequisite for having and analyzing data is having this data. So our library has a mechanism inside that enable the applications that are running our library to automatically produce at runtime data with useful information for us, like what is the library version they are running, which are the list of activated features, what is the Java version, developer info, and so on. So all of these data are produced at runtime by the application, and we collect them runtime, and we show them in this colorful Looker Studio dashboard that are really our source of truth when we need to know how the community is using our library. So this is a couple of examples of how we use data. The first one is for supporting the decision process. And in this particular slide, I'll show you a graph that of one of our dashboard about the feature adoption. No? So that our libraries includes a lot of features that can be either opt-in or opt-out, and the user can decide whether to enable or disable it. And it's very important for us to know what is the trend, how many teams, how many applications are running a particular feature, because this is important at the time we need to introduce a change to assess the impact, or we want to deprecate something, or we want to introduce something new. So every time we need to do a change, we really care about and really check this data. In this particular graph, you can see, for example, that there is a very core feature, the one represented by the blue line, which adoption is constantly increasing. And in contrast, another one represented by the pink line that has been deprecated, and we can see that the community is moving away from this feature. So our communication probably had an impact, no? So we can measure it. Another good example are these two features, the one represented by the gray line and the other one by the yellow line, because we decided somewhere last year to deprecate the one and replace it with a new feature, the one represented by the yellow line. So we can see that actually the the transition of the community from one feature to another, and we have a full picture every time about what the community is using. So this is very important, again, before taking any decision. Another good example of how we use data is for discovery user. So as I'll tell you before, it's an important source of feedback for us, engaging directly the community. So target a group of teams or a group of users and ask them question. No? For example, we want to target the users that are using a given set of features or a given version of the library and so on. So we can use data to identify those users and ask them questions. And to do that, we use this dashboard, for example, that return as it works as a filter. So at the beginning, without any filter activated, we have the full number of our application at almost 500, including dev environments. Let's assume that we are interested just on targeting users that run application in production, so we can use this filter to enable a specific production environment. Then we want to contact users that are using this set of features, SNS, SQS, and monitoring, so we can use this other filter. And one of the latest version of our library. So we can narrow again the search, and we come up with 12 applications. And now we are ready to engage this team and ask them question, oh, how was the upgrade to the latest version of the library? Do you suggest some improvement of our documentation, of our migration guide? Or what do you think this set of features work together? Are you happy? Do you have any suggestion and so on? So this is very important. This is a real practice that we follow in our way of working, let's say. This actually brings us to the third example of practice that we follow when we work with the community, that is interacting with people. So we constantly interact with the community, and the first example of interaction is indeed by interviews that it was I've just mentioned. Another example of interaction is through early access that happen every time we need to release like a new major version or a new important feature, and we need the feedback from the community about this change. So either we engage directly the community, or we send an announcement and the user volunteer to try the new thing. No? And it's really important for us to have this feedback for the community, because they use real application in test environment, but real application, and it's not just our feedback inside the maintainer team. Another example of interaction is through job swap, that you can imagine like an internal Erasmus program, let's say. So there are developers from other teams that decide to voluntary to join the maintainers team for a limited period of time, a few weeks or a few months, and they work like hand by hand with the maintainers, and they acquire a lot of knowledge that they can transfer to the community, improving the self-supportive skill of the community and being also potential contributors of the project. And the last way we interact with people is through the typical support channel, that is the Slack channel, where everybody sends support requests, feature requests, bug reporting, and so on. But we want to highlight that a part of the requests that require us to change things, like feature requests or bug reporting, so we need to fix something. We also take insights from any kind of request. So even if we receive a support request or a guidance request, it's very important for us because maybe we can decide that we should improve our documentation, we should improve our logging, we should improve our migration guide. So we really take care of any kind of incoming request. And this is the last practice that we follow when we work with the community, that is creating narration. So in the slide before, I was talking about the bidirectional interaction with the community. Creating narration is more on the unidirectional way, because we don't want to avoid any discussion with the community, so we don't want to cut the discussion, but we try to limit. So it's important for us to create a narration and provide upfront all the information that the community may need. So we have different channels to provide this information. There is the typical one, the news channel, a Slack channel, where we send a general announcement, an important release, discover vulnerability, and so on. Then we have also a blog post, a blog, where we send posts like more or less once a month. This is an example of the post for the Spring Boot 3 adoption. And then we also send like a newsletter once a semester, more or less, with a long-term view, let's say, with a summary of the achievement, a summary of what is the ongoing work, and a view of the upcoming feature. So this is very important and provide a lot of information to the community, and hopefully most of the information help the community to self-support and avoid the discussion. Limit the discussion, sorry. Yeah. So these are the takeaway of working with the community. As I mentioned, it's important for us to collect data to assess the impact and to reach the target users. It's important for us to be custodian by involving the community, accepting contributions, and it's important also to narrate and discuss in the right proportion. So we don't want to cut, but we don't want to discuss all the time. So these are the takeaway for about how we work with the community. Now Jacek will talk about more technical, maybe more interesting topics for you.
To strengthen the fact we have told you a lot about our data and community is that we would not survive without the data at this scale. Like, really, there's so many cases when we use, so it was so fundamental. We even talked to our product owner, we put this section first, even though for technical people it might not be that interesting, but because it all starts with data, and I'll show you also in the sections later how. So who of you is more interested in design or engineering? Design? Most? Both, okay. Both? Okay. So design. We'd like to focus on design on two levels, domain and modules. There was a question after Michael's presentation if you can do domain-driven design in the technical work. Yes, we think like we have to be product owners also, because there's no better people to talk about the requirements than us. We do have a product owner who's helping us really with the mission, with the vision, with all the Sean Ellis tests, user segmentation, and inspires us to produce more data, but we need to be out there and talk to the users. So we keep that to doing iteratively. So we iteratively discover the domain, refine it. It translates directly to our repository structure and the table of contents. So think you can unplug security and documentation and repository and put somewhere else. That helps many things. It helps with collaboration, contribution, and evolutions, not just empty words. I'd like to show you in the next slides how it helps with these things. So collaboration first. Again, it starts with data. We know who uses what. Like most people use the core functions, fewer people use events. Maybe not everybody uses security, maybe they use a different security. That's important because maybe there's a niche that we haven't addressed yet, or maybe there's a security problem. Now it's iterative because we discovered over time we mostly talk about AppSecs and pen testers about our dependency management, of course, SNCC, and a security. Yes, so it's a domain, and it's formed through various factors, not just how it changes, but also what the speaking partners are, right? Again, cloud runtime engineers are mostly interested in our cloud access, environment, and web communication aspects. If we talk to a user, they say maybe it's in the scope of your project. We say, sorry, this is not in scope of our product because we focus on this. It's easier for us to sort of negate requirements, say this is for someone else. Also, if they want to contribute, we can easily focus on a single domain. Also, recently I was trying to do a native sort of experiment, try to make it work. It was obvious to me I have to do it with core because if I make core native ready, then maybe users can start with it. And there's most users that can use it. So this is how we can use it in many ways. Now, it also helps with evolution. This is an actual case. We used to be on Beanstalk, in AWS Beanstalk. and moved to ECS that has a different setup. So different credentials, different logging, also for some users, different packaging, of course. So our platform had feature parity. It was very easy to reason about it. We only knew that we want to change the two domains, the access, the credential chain, for example, maybe region setup, and an observability access. It's different setup of logging, for example. And user could mostly do lift and shift. If you ask them, they will not say it was lift and shift, of course, but it was much easier in their own sort of referral. Now, if you wanted to move to something more powerful, like a mesh, then it can take over some of our platform. We can become a syncing platform in the Georg Hopf's fantastic article about floating and syncing platforms. And we remove some functionality, and our user simply picks fewer modules and can start using the features of the mesh. And we actually did experiments with EKS. We don't want to go there, but we are ready for it, because of the domain, basically. Now moving on to modules, this is not any sacred rules. These are some empirical considerations we have developed over years. So we started doing some things more than before based on observations. And these rules or observations are the following. A module should do one thing and be easy to explain. So this seems like an S in solid a bit, right? So the control questions would be, can I explain my module in a single sentence? So does it do one thing, basically? Is there a separate use case for it, or maybe they are used as a bundle? So if not, maybe the module is too big or too small. An example, loading a property file from S3 and refreshing it periodically. This is an actual module. We have a couple of such modules. And working that way, we cater to the sort of the good parts of the mixer, saying they are modular, simple, easy to self-support, easy to contribute to, because there's like a few classes in Java, anyone can contribute. A second rule, providing predictable configuration properties. It can go wrong in many ways. Like, we have to think up front about the namespace. Like, is the namespace okay? Does it fit my organization? What else is out there? Can I actually evolve my schema also without breaking change? Like, if I have done it wrong, saying refresh true here, then I cannot expand the tree, so I have to make room for new properties. You know, maybe it's obvious for some of you, but it's still something that people get sometimes wrong. So we also talk to other library authors, discussing with them how libraries can be made more maintainable and discuss blog about it, how to do that better. Configurability, predictability. A third rule, allowing extension by making the API clear. So this is a tricky one. So we haven't gotten it right yet, but we have an idea. So do I want my users to extend behavior and change behavior? Like, imagine they are on an older version of a library. I cannot change it. Retrospectively, I don't want to change it. And he's stuck. So yeah, I actually do want to allow him to override every single bean. Yeah? Why not do that? But those can change, right? This creates coupling. So we now have an idea that, yeah, let's not block users generally, but make it clear what is an API. This is actually an idea. We haven't done that yet. But that feeds to two things, like predictability, again, extensibility is there, but again, we can make it also a bit more controllable. And we can also create living documentation based on it, because we could produce those API beans to a module reference that you have seen. Fourth rule, making modules similar and natural in use. Of course, there's no golden rule here. Will the module behave similarly as another one? Yeah, that's not tricky if the team is aligned on how we want to see modules. It's tricky if you have contributors and they have their own ideas. So it takes time to discuss with the contributors that they may have fantastic ideas, but it's very important that when our user knows how to use one module, he will know how to use other modules, because it will help him self-support and test, and we are predictable. We are not like a bunch of guys. Yeah? In our case, that means the modules have properties to turn them off, so for testing may be good. Good loggers, so people expect that when they turn on the logger, they can usually see something useful, that they are extensible in a similar way, they have similar metrics, and so on. So this is like, in our word, the common sense. In your word, it would be something else, maybe. Something we found over time that conditional logic is often seen by our users as magic. And this is also a tricky one. I'd like to ask you one question here. But let's first lay out what I mean by magic. The control questions we ask ourselves, are most users expecting a certain hidden synergy? So they know that if they have a condition, if there's a conditional on class, that will trigger when they add, say, micrometer, feign, or whatever, or maybe a load balancer. Yeah? Does the user or many users complain about certain magic, yeah, in a certain place? Or is he even in control of the condition? So is it not like he cannot control it because actually he adds another library that will turn on the condition, that will trigger it out of his control? So maybe if some of those questions, the answers to them are negative, maybe we should remove the condition and make it just a simple starter that is like just put there and do one thing. A case study that I would like to ask about your intuition. We have a starter, whatever it does, it turns on certain features from an auto configuration, right? This green part. But it doesn't turn on the metrics here, the metrics that are a micrometer metrics. Would you expect that if I add a starter actuator, that it will start producing the metrics? How many of you think yes? Okay, how many no? Okay, yeah, so we think yes also, but we would ask our users, because if our users don't expect it, we would probably not do it. Yeah? I mean, this is common sense in Spring Boot. If something is common sense in our head, it doesn't have to be in their head. Like the mental models, again, I'm actually very inspired by the talk of Michel. I'm sorry, he's not paying me money. Yeah, so again, predictable. Sixth last module design rule, providing drop-in test modules. A good question is, when do I actually want to provide a test module to a user? Would I provide a test module for every single module, or a test feature, a test double for every single module? So here is like actually a question and an answer. Is it something that users will have to mock often? That comes from the Google engineering, the engineering at Google book about the section about faking. And we also do it like this, exactly. Yeah? If it's something that users have to mock often, we provide a test thing, something for SQS, something for SNS, something for security server, and something for integrations usually. Yeah? Nowadays, in the test containers world, we probably have less need for that. So again, we'll probably deprecate those modules if there's no more need for that. We'll see adoption drop. We try to react to what's there, yeah? But in general, maybe one small technical detail. For those modules, we use a bin registry post-processor. So it's a good thing because for those of you who don't use this mechanism, it's a moment when the bin registry has already been sort of filled, and I have a chance to replace the bin in the registry before it's actually created. So whether it's my bin or the bin that my client created, it will not even be created. It's sort of reliable. Maybe somebody can tell us that there's a better mechanism, but it works for us very well. And we try to be, again, predictable here. And that's it when it comes to software design rules, at least, or a peak of that. So in the domain, we try to understand scope and visualize it to make collaboration evolution easier. When it comes to the modules, we create mini products with own life cycles that increases agility. We make them simple, predictable, and easy to contribute and configurable. So that's the balance from the mixer. Yeah. And now we move on to the last section, 9 minutes. We're really grateful that you stayed with us. We know it's the end of the day. You must be very tired, but I hope it will be at least a bit interesting. We chose, again, only 3 engineering practices. The libraries testing, because we think it's interesting, slightly different testing than some of you may have seen in the applications. Our agile release model, because we obviously deal with waterfall libraries that release waterfall or waterfall events, and we have to somehow work around it to provide our users with an up-to-date stack. And agile documentation, because we have huge documentation, but we want to make it maintainable. So it's a challenge, but we have some tricks here. So very briefly. our test pyramid, I talked to the test containers colleagues today before the session, and they said, yeah, maybe what we have is a funnel. I also think we actually have a funnel. We have more valuable tests towards the top. Maybe not quantitative, but qualitative. I think we have the most valuable feedback from the top part of our, I even draw a trapezoid, actually. We will only talk to you about some of them. We actually also have a community with the early access that Fabio mentioned, super useful. They provide a lot of value. They are a blessed relief to us. And today we'll also only want to focus on 4 types of tests that we think are interesting, and some of them are, I think, specific to library testing. From top to bottom, you'll see a small thumbnail at the top to help us navigate. Say, what we call sandbox test, the first of 4, is for detecting high-level regressions. So you can think, depending on if you use terminology of Fowler, out-of-process test, I would say. We have 12 combo applications, maybe the size of pet clinic applications, or maybe smaller, that cover many features from our, like mashups, they cover many features from our libraries. And we mock their neighborhood, and we test them in parallel, so we see very quickly, okay, something's broken in the messaging. That usually happens after upgrading something from the AWS or Spring Cloud AWS. And the technical stack for it is very common nowadays. We use a local stack, test containers, we use Docker Compose. After talking to the test containers people today, I think we will switch to the generic containers and to the test run from Spring Boot, because it will probably be better, but we are not there yet. Now, I will not tell you, because Josh has done a good job of saying, I know now most of you use test containers, so it's a very typical test containers test. Before each, we just enable a lot of logging, just in case something goes wrong. We assert the application URL, a typical Docker Compose stack, nothing really to say about. But the good thing about these tests, we really like them. They are very good for onboarding, ad hoc tests, chaos engineering. And as I said, we may adopt the generic containers approach really soon, because I really like that. Dependency diff. This is our own invention. So we found that because of how Spring Boot works, the transitive dependency tree is really important for our users. So what we do, we want to make sure there are no regressions in the dependencies. And when, say, we upgrade Spring, we want to know what's going on. And we do our own rework, like say, changing of modules is many times more doing in the annotations and dependencies than the actual code. So the setup is this. It's a huge transitive dependency div, a colorful one, using the tool listed here. And we do a manual check. We haven't automated it because we don't trust AI yet, but we are not smart enough to automate it well. And it looks like this. Say this is an expected change. Say logback is up by 1 patch after upgrading Spring Boot. This is good. So this is something we expect. And now I'll show you something we don't expect. Obviously, if I have suddenly more dependencies, or I have a scope change, that can be, as you know, dangerous in Spring Boot. So when we have done something tricky in the dependencies, we usually do a manual check. We have a checkbox in our, say, checklist, and we can make sure it works. This is, again, quite high in the, as you see, because we do it on the whole set of dependencies. Moving on, condition evaluation reports. So Josh has asked you about the test containers, but didn't ask how many of you use a condition evaluation report. Okay, so let me explain. This is a report that Spring Boot creates when you turn on a property, and tells you which auto configurations from your end libraries that you use are turned on or off, and why. So which properties were, or properties or classes were triggering. This is especially good when you deal with magical libraries. Yeah. So our library stopped being magical. I realized we stopped actually recommending users to use condition evaluation report because there's no need anymore. But we used to do it a lot. Yeah, please turn it on and see why the auto configuration is not there. But nowadays, we actually went one step further. We actually automate that as a unit test. We want to check if there are no regressions in auto configuration, our own code, and also detect it's not like not trusting Spring. It's more like if Spring provides something interesting, maybe a new micrometer synergy, or maybe something new in the say resilience4j world, or say resilience4j libraries with Spring Boot, the other way around, then we know it. So we can say, oh, this is something interesting, maybe we should look at it. And it looks like this. We have a blueprint. This is a YAML file. We say we want all those auto configurations and sub configurations to be, say, in my context, conditions positive, also negative. Oh, sorry. And the test is very simple. Please do not try to analyze the whole code, but it's, as you see, it's a Spring Boot test with context injected, and there's some syntax sugar to extract the report, and we assert the report against the conditions. So we know something new appeared, interesting, not interesting, fix it, or just add that to the blueprint. It seems like something that takes time. Yes, it takes time, but it's really helpful to us. The last type of test, I will not say much about it because it's something very obvious for Spring Boot auto-configuration creators. Testing complex condition coverage in auto-configuration is done using application context runner. This, you can read more about it if you haven't in the Spring Boot documentation. It's a fast sort of bootstrapper of, say, mini context that can add auto-configurations and assert them against presence of beans or the other conditions, like based on whether a property is true or false, whether a bean or class is there or not. It's a bit tricky to set it up well, but it's very fast, so this is the benefit. And we use it, not a lot, because as I said, we don't have complex conditions anymore, but we do that at the module level in those modules that are still complex. That's it. So that's testing. We have two very short sections to cover. I know the time is up, so I'll go fast. Our agile release model to produce 200 releases a year with things like Spring Cloud Ilford, Spring Boot 3, Java 17 on the road. We try to smoothen the road, so they have this waterfall here, and we want them to be like this. Yeah, we want them to have small steps. So we do all the things that Fabio mentioned. We involve a community in the early access. We do moonshots, snapshots. We have been on Spring Boot 3 since M1. Yeah? And released small things. Read what Phil Webb wrote about moving on to security first, the new security, 5.7, 5.8. Moving on to Java 17, telling users they should not try to do it all at once, trying to do it in steps. I think we even have a presentation about it today or tomorrow. Do you know maybe? About moving the journey to Spring Boot 3. Yeah, I'm sorry. Anyway, I thought I saw one. So we employ a lot of tactics, and especially we employ empathy, because we know the data, we know who is using what, and we know how fast we can go to not lose or annoy our users. So this is very important. But that's enough data for a separate presentation, not do that. And documentation, I'll only say the challenges has to be good, has to be big, and has to be up to date, and has to be maintainable. So this is the challenge. And we'll only say we have already covered what we wanted to say about it. We've got 5 types of documentation very similar to what Spring Boot has. We have high-level concepts, guides, one-pager reference with a Control-F, Command-F feature, the SPA with modules, and our blog. So the trick is very simple. We only do regular updates to the reference because it's part of our job, and the rest is either automatic, as I have partly shown, right, because this is like a living documentation, or written very rarely. Yeah? So this is how we can have both documentation that's comprehensive and up-to-date. Right, takeaways. Libraries testing, different focus, different tools. Worth to have good tests if you have 120 teams. Agile release model, looking ahead, breaking waterfalls, involving the community. And documentation for large communities is multifaceted, living, and automated. So we hope we have shown some interesting stuff at least, and really grateful that you stayed with us. If you want to take a screenshot because or a photo because this slide will be shown only for a couple of seconds, I don't want to keep you. 4, 3, 2, I have one request, because this is a team effort that we are here. We have our communications lead. She'll be super happy if you take a photo of our, QR code. It's also because of her, she convinced us that we can achieve it to be here. So we're really proud and humbled at the same time. Thank you. And now, I mean, time is up, but in case you have questions, we are here. So thank you.